Hey, welcome back. And now we are going to use GLPK to solve the diet problem. We are going to show you how to express GLPK using GLPK input format, and we are going to use the ample-like input format, which is called mathprog. Okay, and we are going to do things in mathprog and show how we can model the diet problem. So we'll have a diet.model, and we can show how to enter the data for the diet problem. And these files are already available online. You can download them, examine them, and make sure that I'm not doing something wrong, and understand how to do this with GLPK. Okay, so what does the problem data look like? So the problem data looks like this. So you have a scalar parameter n foods, that's the number of foods. That's the number of food items. N nutrients, that's the number of nutrients. Costs, which is a vector of n foods comma 1, so cost is going to be a vector. Okay, that says that's a cost per unit of each food. Caloric data, it is going to be a matrix, and the rows of the matrix corresponds to foods, and the columns correspond to nutrients. Okay, the ith row, jth entry, aij, corresponds to how much nutrient J does food I give us. So how much of nutrient J does food I give us? So we can talk about how much of vitamins do carrots give us, or how much of carbohydrates does rice give us. And these are entered in this matrix called caloric data. Okay, and we have the Excel spreadsheet for that matrix given to you already that you can look at your convenience. We have two upper bound and a lower bound on the number of nutrients. So upper bound says for nutrient J, what's the maximum amount of that nutrient that I should get in a day? So for carbohydrates, I could say I shouldn't get more than 700 grams of carbohydrates in a day, maybe. Or I shouldn't get less than 500 grams or 400 grams of carbohydrates. So there are limits on how much carbohydrates that they can get. And the lower bound matrix vector and the upper bound vector tell me for every nutrient the lower bound and the upper bound on the nutrients that I should get in a day. And these are recommended by USDA. And we have this data as part of the Excel spreadsheet as well. So this is the model file. It's available to you as diet.model, I believe. Okay, you can download it and examine it. And this says the same things I said in the previous slide. You have parameters, number of foods, number of nutrients. You have the caloric matrix, which is a two-dimensional matrix, which is n foods times n nutrients. Then that's the caloric matrix. You have the lower bound vector, the upper bound vector, and the costs. Okay, lower bounds on the nutrients, upper bounds on the nutrients, and the costs per unit is on the food. Okay. Now we instantiate our decision variables. Okay, this says you instantiate variables x1 through xn foods, where xj tells me how much of the jth food should I be eating in the optimal solution. And now you minimize an objective, not maximize, and the objective is going to be the summation, okay, over I going from 1 to n foods of the cost of the ith food times xi. Okay, cost of the ith food is already given to us as a variable. The data will give us the cost, and then we just say it's cost of I times xi and sum it up, and that's the total cost. Okay, now the only constraint that we need to enforce is the bound on the nutrient. We want to make sure that the person gets the nutrients that they have to get. So for every nutrient, k going from 1 to n nutrients, you want to say that the lower bound of the nutrient is less than or equal to, and this just represents how much nutrient do I get. How much of nutrient number k do I get with my current solution? Okay, and that's the summation over all the foods of how much of the food I'm eating and how much of nutrient k does the food give me. So this gives me how much nutrient k do I get, and that better be between lower bound and upper bound. So you can say LB of k less than or equal to the amount of nutrient I get less than equal to UB of K. And this is a template that expands into n nutrients constraints. It's not a single constraint, it's n constraints that has been condensed into one single expression. Okay, I solve, I display X, and I go up. Okay. Now how does the data look like? And this is available to you as diet.data. It's really big and I can't show you everything. So it says param n foods is 64. It says there is 64 foods. There's 11 nutrients. And then I print out the caloric matrix. I've renamed this to cal data. Okay. And this is a matrix and I print the indices of the matrix. So this is n nutrients. And this is going to go down. This is n foods. I can't show you the entire matrix. It's a 64 times 11 matrix. And you can see the entries. So this is the first row, the second row, the third row, and so on. And MathProg has a specific way by which the matrix has to be entered. And I suggest you look up the manual to understand exactly how the matrices are entered. You have to enter their column indices and their row indices as well as the data in the matrix. It's very specific to MathProg, and you have to go look up the manual to understand this format. And once you understand this format, it's a piece of cake to write down this data. Okay, I took the Excel file and just had it print out this data for me. Okay, so then you can run it. So you can say GLP solve, use diet.model for my model, and use diet.dat for my data. When you do that, it prints a lot of things which I've condensed to this. It says, okay, optimal solution found, great. And it starts printing the optimal solution. And since there are 64 foods, I've just shown you the first 10 foods. Okay, this is rather inconvenient because, first of all, a lot of the foods are just 0. It tells me not to eat them. And then some of these foods have answers, and there is 64 of them. And I do not know what the second food is. What is the second food? I don't know. So this is very hard for me to read. Maybe I need something better. Okay? And the nice thing is that the richness of AMPL allows you to say things that are much better using printf statements and other statements. So I have a more advanced model that I call dietset.model, where I'm allowed to name the actual foods. I give the names of the foods as well. And I somehow use printf statements right here, and please consult the manual for this, to tell me what foods I should eat in a very succinct printout. Okay, and you can do this. This is quite easy to do. You just have to spend half an hour to an hour with the manual, depending on how good you are with these things, and then you are immediately there. You can immediately take up and write this program. I highly recommend you to examine the two files that I've posted, dietset.model and dietset.data. Okay, and these two files will give you the diet problem where the names of the foods are also taken into account. I highly recommend that if you're interested in using GLPK with MathProg, I highly recommend that you examine it. Okay, and when you do so and you run this, there's going to be a bunch of printouts, but then here is my printf statements that says, okay, optimizer tells us to eat this many units of raw carrots, baked potatoes, skim milk, peanut butter, and air pop popcorn. Okay, and this is the same solution that Shalom got using the other tools as well, and it's great to see that we get the same solution, which tells us we are doing something right. It also tells us the bill comes to under $1. If you eat these 5 foods, which I highly recommend that you do not eat, okay, this is not meant to be a practical exercise because there are other things like salt, amount of daily consumption of salt, cholesterol, and those kinds of things which we haven't taken into account here. So do not eat this kind of food. It may be unhealthy in the long run. We do not want you coming back to us and saying, I lost my health because I followed your advice. Please do not follow our advice and eat this food. But the optimizer for this toy problem tells us to eat these foods to get the kind of nutrients we want to get. And this is not comprehensive. Do not do this. I will say this very clearly. Thank you. And it finally says bon appetit. I do not think this is appetizing at all. 4 units of air popcorn is not my idea of a balanced meal. Okay? All right. So that shows you how to solve the diet problem using GLPK, how to set it up, how to solve it. And I hope that in our discussion group, we are going to have a much better discussion on how to get the diet problem to give us some good answers. We will have a paper by Danzig on his personal experiences with the diet problem, also posted for you to study. Copyright restrictions may not allow us to post it, but we can at least post you a reference to the paper and have you find it by yourself online. So I hope you enjoyed this little tutorial on GLPK, and I will see you in the next lecture. Thank you so much.